In this video, we're going to take a look at arrays and slices in Go. Now in Go, slices and arrays are both used to store sequences of elements, but there are some important differences in both the behavior and usage of arrays versus slices. Let's start off with arrays. So arrays in Go are a fixed size sequence and they have some characteristics. So as I said, they are a fixed length. They are passed by a value rather than reference. They have a fixed continuous block of memory allocated when you create them. And there are a few ways to create arrays. Let's have a look at some ways we can actually create an array, and then we'll discuss the behavior. So the first way is to just simply declare a new variable. We'll call this R1. You then use the square braces. And as we said, because arrays are a fixed length, you have to pass in the size of that array. Let's go for an array of 5. You then pass in the type. So that's one way to declare an array. This is an array of 5 and it's an array of integers. Another way to declare an array would be to do something like this. So we declare an array of length 3, it's of type string, and then we'll go ahead and actually create that array. So string, and then we'll pass in, say, programming languages to this particular array. So that's another way to declare an array. Again, it's a fixed length, so you pass in the size, you then pass in the type. You can, of course, use the simple declaration or the short declaration with the colon equals. And let's go ahead and create an array of, say, float 32s. And then we'll pass in, 1.1, 1.2. Oh, I've got the wrong thing. It needs to be curly braces, so 1.1, 1.2, 1.3, and 1.4. So this is an array of length 4 of the type float 32, and then we've passed in the values there. Another way you can declare arrays is using the simple declaration again, and this time we're going to pass in the ... And this syntax here basically says to the compiler, create an array of the length of the items that I pass in. So let's do an array of integers, and again we'll pass in 1, 2, 3, and basically the compiler will see that this is an array of length 3, and it will just create this array of a fixed size of length 3. So you can think of this as basically whatever the length of the actual data that we pass into the array. You can also pass in the actual index of the items you want to pass into an array. So let's have a look at that and how that works. So again, we'll do an array of length 3, again integers because they're nice and easy. And we'll say that we want the 0 index to be 1, and we want example, and then we can say we want the second index to be 2. And that's a valid way. And basically in this array, the 0 index will be 1, the second index will be 2, and the first index will be 0. Okay, let's look at some slices now. We'll then do a comparison of arrays and slices and look at some examples of how we use both. So slices are a dynamic, flexible view into arrays, and they have the following characteristics. They are a dynamic size, so the length can change during the program's execution. Slices are passed by reference, so the slice contains a pointer to the underlying array. And this pointer has kind of 3 components, similar to what we saw with strings. You've got the pointer to the first element, you've got the length, and then you've got something called the capacity, which we'll cover a bit later on. And in terms of the declaration of slices, let's have a look at how we can declare some slices. So we'll do slice 1 here, and we'll make this an integer slice. So the difference here is we don't need to pass in the size of the slice, it's a dynamic size. Same as arrays though, we do need to pass in the type of the slice. So again, we can do slice 2, and we can make this a string slice, and we can do similar to how we do with a array, but this time we don't need to pass in the size of the slice. It's dynamic, as we said. Again, we can also use the simple declaration syntax. So we can do, again, let's do float 32, and we can pass in, say, 1.1, 1.2, and that'll be totally valid. Again, because we don't need to specify the size of the slice, they are dynamic. We can also create a slice using something called the make function, and this will be a empty slice, and we'll make it of length 5. And what this make function does is it essentially creates a slice and allocate the memory that is required for that particular slice. So we've created a slice of integers and we've given it a size of 5. So that means in the memory we've created a slice and it's got a sequence of 5 bytes. They're just nil bytes for now, but that's quite useful for the future. We can also do the same thing with the make function, but this time we can pass in what's known as a capacity. And as we know now that slices are dynamic in size, so the size can change, but there is also this concept of a capacity, and the capacity is basically the maximum size of that slice before the compiler needs to reallocate some memory for it. Again, we'll cover it a bit more later on, so don't worry too much about it for now, but just good to know that that's a syntax that you can use. We can also create a slice from an array. So if we create an array here, we'll create an array of 3 and we'll create integers, 1, 2, 3. So with our array there, we can create a new slice and we'll use a simple declaration here. We'll get the array and then we'll just grab, say, the first and the second item from that array. So we've seen this syntax before. This is basically grabbing a slice of this array. So we'll grab 0, 1, 2, and we'll create a new slice from that array. It will not change the array. It will not impact the array at all. We're basically creating a new slice in memory here that just takes these values and creates them into that new slice. You can, of course, also do a slice of a slice. So you could also do something like this. It's a slice 6. And we'll take the 0 element and the first element. Again, that's a valid syntax. In terms of the key distinctions for declaring arrays versus slices, for arrays, you always need to pass in the size of the array, whereas with a slice, you don't. It's a dynamic size in a slice, whereas a fixed size in an array. So an array will always have a number in the square brackets. A slice will not have the number. Slices can be created using the make function, but we cannot create arrays using the make function. It's only for a slice. Arrays can also use this dynamic syntax here, which grabs the size of the items passed in and then creates an array of that size. Slices cannot do this, again, because they are a dynamic size. Now know that the difference in size between arrays and slices. Arrays are a fixed size, and that's determined at compile time as you have to pass in the size of the actual array on its declaration. Slices are of dynamic size and they can grow in the program. In terms of the memory behavior, so arrays are value types and copying an array will copy all of the elements of that array. Whereas slices are reference types and copying a slice copies only the reference to that slice. We can take a look at that as an example. So I've just got a simple function here. I'm going to go ahead and create an array here. I'm just going to create it of size 3 of an integer, and we'll just do 1, 2, 3. If I go ahead and copy that array, so we'll create a new array here that is just a copy of our existing array. I'm then going to print out the address of those pointers, of those arrays. So let's look at what we're doing here. We're declaring an array of size 3 with 1, 2, 3. We're then copying that array into this copied R variable here. I'm then going to log out the address of the first array. I'm then going to log out the address of the copied array. And we'll see what happens here, basically. So we'll see that these are different addresses. So this one ends in 0018. This one ends in 0030. And that's because with arrays, you copy an array, you copy all the elements into a new piece of memory. Just one thing to remember. So arrays are passed by value. With slices, however, slices are reference types and copying a slice copies the reference only. Let's take a look at that. So we'll go ahead and create a slice here. Again, we'll just do an integer slice. Remember, no size needs to be passed into that because it's a slice. And again, we'll do 1, 2, 3. If we go ahead and copy this slice, we'll do the same thing we did with the array. And let me just grab these log statements rather than typing them out because it'll take a while. Okay, so let's discuss what we're doing here. So again, we're creating a slice of integers with 3 integers in it. We're then copying that slice over into the copied slice. We are then going to print the address slice of the slice's header. We'll then do the same with the copied slice's header. We'll then print out the address of the slice's first element and the copied slice's first element. And we'll see what happens here as well. Okay, so that's a little bit complicated. So what we can see here is that the slice and the copied slice have different headers. So they are in different memory addresses there. But the actual first element of the slice in both of them is the same address. So the first element is the same, the headers are different. And that should start to make sense when we think back to strings, for example. So similar to strings, slices have this slice header here, and you have the pointer, which points to the byte memory in sequence. So that's going to be the underlying array. So this address here, and as we know, that's the same address in the case of the slice and the copied slice. And it also has the length and the capacity. However, when you copy over a slice, you create a new header, but the header has the same reference to the first byte in memory for the shared array at that point. We'll see this a bit more when we do the next thing of passing it into a function. Just need to know that if you copy a slice, you're copying a reference to the header itself, and that has a pointer to the underlying byte array of that particular slice. So again, the headers, different addresses, the underlying slice, so the underlying data has the same address because it's the same data. The passing of slices and arrays by value and reference a bit more with a kind of more concrete example. So I've got a function here, main, and what I'm doing here is I'm creating an array of length 5 and it's just got some integers within it. I then go ahead and print the address of that array. I then do the same sort of thing for slices. So I've got a slice here of integers. Again, it's got 5 integers in it. I then print the address of the slice header, so of this particular thing here. After that, I then print the address of the underlying data, so of this element here. I print that address. I'm then going to log out what that item actually is, so I'm going to log out 1 at that particular point. I then call this function blah, which takes our array and our slice as arguments. And if we jump into that function here, we can see that A is our array of 5 integers and B is our slice of integers. I'm then going to log out the address of our array, then the address of our slice's header, then the address of our slice's data. I'm then going to go ahead and change the first element of our slice. I'll then print out that element of the slice in the blah function. We then come back up. And again, I'm going to print out the first item in our slice just to see what it looks like. A lot going on here, but we'll walk through it and we'll explain exactly what's going on. If I go ahead and run this, we'll see what happens. Okay, let's make that a bit bigger. Let's walk through the code and we can explain what's gone on here. So we've got our array here. The first thing that happens is we print out the address of our array. And we can see that's 16120. We do the same thing with our slice. So we've got our slice header, our slice data itself, and we can see that the first element in our slice is, as we expect, is 1. We then call the blah function here. So we're passing in our array and we're passing in our slice. We can see here that the array address is now different from the initial array in our main function. And that's because when we pass arrays into functions, we are copying the array into a new slice of memory. So that is passed by value. We've copied it over and we've created a new array. For our slice header, we are doing exactly the same thing. We are copying our slice header and passing in a new version of that slice header. So it's a new memory address here. We can see this one's C228, whereas in our function, it's C240. So we've now got 2 slice headers at this point. What you'll see, the actual underlying address of the slice's data is 16108, and in the function itself is 16180 as well. So the underlying data for our slice header is exactly the same. It's a pointer to the same place in our memory. This is because when you pass in slices, you pass them in by reference. only the header itself is copied over. So we get a new header, but the actual pointer to the data points to the same bit of data in our memory. We then go ahead and change the first element of that slice's raw data to 100, and we print it out. And we see here that in our function, it's now 100. So before it was 1, it's now 100. And because slices, the underlying data is passed by a reference, we've just copied a new header over. It's still pointing at the same bit of data. In our main function, when we then print out that slice element again, so print out the first item in our slice, it's now also 100. That's because the underlying data, this array here, is passed by reference and it's been changed. So it's now the same data, two different headers. And that's because, as I've said, we copy over the slice's header, but the data points to the same reference. If we were to do the same actually with our array, we can see the difference here. So let's change our 0 to be, let's call it 1,000. And we'll also print that out as well, just to make it clearer. So A. We'll copy that, and then in our main, we can print this out as well. So this will be R0 and R0. Okay, let me do that and run that as well. Okay, so we'll see here that the difference between the two. So we've run this and we can see that in our blah function, A0, so the array 0 here is now 1,000. Whereas in our main function, it's still 1. Here, it's still 1. And that's because the array is copied over. It's an entirely new space of memory. And we can see that here, A00 versus in the function, it's A090. So it's a entirely new bit of memory. So hopefully that just demonstrates that arrays are passed by value, slices are passed by reference. And with a slice, only the header itself is copied, and the header has that pointer to the underlying byte sequence in memory. So when would you use an array versus a slice? Well, you use an array when the size is fixed and known at compile time. You want the value semantics, so you want your copy to not affect the original, or you need a very small sequence and you need it to be performant. You'd use a slice when your size might change. You don't know the size of the data up front. You need the reference semantics, so you want to pass by reference. Remember, we just copy the header, not the actual underlying reference to the data itself. You're passing the sequence of data to a function and you want to manipulate that underlying data. And honestly, you're most likely going to use slices pretty much exclusively unless you have a good reason to use an array in Go. Arrays do have some performance benefits, again, because you know the size up front. The compiler can optimize for that. But generally, you'll use slices in pretty much all your programs. And unless you have a really compelling case to use an array, just use a slice. A few minutes to give you an example of some methods and stuff that you can do with slices and arrays. I'm going to go ahead and create a slice called scores here. It's going to be an empty slice of integers. And we're just going to keep some player scores in here, for example. And let me just take a log so we can see what's going on there. The first thing I'm going to do is I'm going to append to our scores slice. And the append function, basically all it does is it's a built-in function to add elements to the end of a slice. So we've got an empty slice here. This is going to be empty. We're going to go ahead and append a score to that. Let's add in 85, for example. And then maybe let's do it again as well. And let's add in, say, 670. And we'll do another one as well on the same slice. If we then go ahead and just print those out, we should see that we get the slice with some data in it. So initially the slice is empty. It's got a length of 0. We've done an append and then another append, and we've got some items in our slice. So with append, you can pass in multiple elements to your slice. With append, you can also append slices themselves. So let's create another slice. We'll call this one more scores. Again, it's going to be an integer slice, and we'll say this is 1, and we'll give it 29. We can then go ahead and append that to our scores. So we'll append scores. That's the initial part of the thing, of the slice. We'll then append more scores, and we're going to use the syntax of ... which basically means append everything within this slice into this slice. So we're taking all of the elements of our more score slice, and we're going to append them into our scores slice. And if we go ahead and log those out again, we should see that we get the new slice has all of those elements within it. So that's just one way that you can use append. Another thing you can do with slices, if we create a new slice here, let's call it names, and we will call this a slice of strings. And let's add in some names. So we've got Tim, we've got Bob, and we'll also have Jess. And let's call Zach as well. We then go ahead and just print out these names, and like so. We can then do some sorting. So you can import the sort package, which as you would expect does some sorting. So we can sort our strings, and we can just pass in that slice there, and we'll pass in names. We can then just go ahead and log out those sorted names, and we should see that, as we would expect, the names get sorted. So before it's Tim, Bob, Jess, now it's Bob, Jess, Tim, Zach. So that sorts them alphabetically, in this case by the first character, I believe, of the string. You could also sort them inversely, so you can do sort.sort, and this is a method that takes some data. So we'll do sort.reverse, so we'll flip it basically, and we'll sort by an integer slice of scores, for example. So we'll pass in our scores. Oh, it's auto-completed for me there, which I didn't want. So we'll pass in our scores slice rather than creating a new one. And if we go ahead and print that out, we should now get our scores in descending order. So from highest to lowest. So again, this is the sort function here. Take some data. We're taking our integer slice, we are reversing it, and then we are sorting it. And we get a descending list. So those are just some quick things that you can do with slices. Okay then, so hopefully you now understand a bit about slices and arrays in Go. In the next video, we're going to take a look at maps.